The Roman shipwreck LSG4 has been discovered in Lyon during a 2-year rescue excavation which took care in 2003-2004 within a car park construction project near the Saône, one of Lyon City's main rivers. No less than 16 wrecks have been found from antiquity to the 18th century. 6 of these wrecks are from the Roman period. This discovery doubled the number of non-shipwrecks from that period in France. The construction of the car park and the archaeological excavation were conducted simultaneously. 3 Roman wrecks were chosen to be kept in a lake near Lyon City as temporary storage. To be removed from the car park, they had to pass through the already built foundations and concrete walls. It is the reason why the already very fragmented wrecks had to be cut in sections. Then they were put on frames to ease transport and storage. LSG4, 15 meters long, has been cut in 6 sections. Part of the boat has been wedged to keep the archaeological position. Sandbags were added to protect the remains. The sand weight also prevents the flotation due to the frame's wooden floor. They were put in the lake with a crane, and a map was drawn to localize the 22 frames from the 3 wrecks. Ten years later, funding and exhibition project emerged for one of the wrecks. LSG4 is to be displayed in the Gallo-Roman Museum of Lyon-Fourvière. Raising operation began with divers who approached the 6th frame very close to the bank. The operation was scheduled in January to avoid as much as possible the inconvenient presence of algae. The operation had to take place by night because the only trail road available was used by a quarry exploitation all day long. Hence, we had only one evening to do it, and it worked, between 5 in the afternoon until 2:30 in the morning. The frames were craned to fit with the loading plant of each truck. We wedged the ribs and the loose plank was formed to ensure transport security. Then we wrapped the remains in a plastic film to keep them wet until the day after for the arrival in Grenoble. The team had been reinforced and split in 2 crews so the operation can continue in Grenoble the next morning. Frames were removed from trucks and rolled in a warehouse. It took 2 days to remove mud and clean the upper surface before launching the fresh water spraying system to keep waterlogged wood wet for the whole dismantling duration. At the arrival of the wreck, we saw how badly the wood and the nails were altered. We immediately made analysis of the iron product. Analysis revealed a high amount of very unstable and dangerous sulfur iron compounds, usually known as pyrite. This in just a change in our plans. We had to remove the nails and to make a complete dismantling of the boat, and that to avoid conservation problems later. It took 3 weeks to dismantle each section for a small dedicated team of 5 persons, 4 conservators and a collection manager. And we were supported by many colleagues. The work was done in tight collaboration with the archaeologist. He was observing every piece of wood as they were removed. We first took ribs, then sides, then timbers, and at the end the flat bottom. To allow the disassembling, we have removed 2,100 nails. The removal of the upper nails allowed to take off elements with a crane. Then, we clean each element from mud and from main iron concretion.
Ah oui, donc on est à côté.
Before consolidation starts with PEG impregnation treatment, we strapped every piece with stitched net or formed rope on a steel shell. some lead sheets have been found nailed at the front side of the flat bottom to repair historically altered wood. We made analysis of the waterlogged wood to regularly assess the amount of unstable compounds. We also used tomography and MEB analysis on representative samples. From this data, we elaborate a theoretical mapping of these compounds' localization and diffusion. It is easier to mold while the wood is wet. The archaeologist made some choice to have tools traces and both sides of a timber which can be repaired. The cast could be displayed near the wreck in the museum with explanation for the public to understand this level of details. Once a month, the archaeodendrochronologist is coming to have a look on every available piece. So we have a complete study of every plank with several points of observation for each one on wet and dry wood. It will give a result to know how many trees were used and how they were selected, to know better the use of the shape, how and when they have been prepared. After at least 8 months of immersion in PEG bath with increasing concentrations, it is possible to dry waterlogged wood with very few deformations. So it is taken to a freeze dryer, where it stays between 3 and 8 weeks. New archaeological observation can be conducted after this operation, as wood shrinkage during freeze drying will let appear some more details, as some wooden dowel put when the ship was worn. A complete drawing of the remains was done. It helped recording archaeological and also conservation data. A complete study, both from the upper and the bottom sides, will bring new data on nautical construction for this period and on the duration of utilization for this kind of boat. At each step of this conservation treatment plan, the archaeologist have an opportunity to make his observation, and after all archaeological data have been secured and reported, conservators can go ahead. With the pirate problem in the wreck, we had to make a several points plan to try to avoid acidification, as it did occur with several well-known shipwrecks. Our first goal is to remove unstable iron and sulfur compounds after specific and localized assessment. we make a complementary coring on dry wood with, amongst others, a magnetic control of the coring product. Once the material is secured, we can start reassembling the small pieces and think about the global reassembling. Hundreds of fragments will be glued and thousands of fragments will be lined up on several levels, iron and foam support. This will reconstitute the boat on its flotation state. Instead of a normal gap-filling paste, we created our own acid-fighting product. We put a slightly alkaline buffering paste in the nails holes, and that's to fight against acidification if it does occur. A very important point is to work with the museum too on the relative humidity rate, because humidity is the main factor of alteration. We're going to make a follow-up and long-term monitoring plan inspired by a survey on what is already done elsewhere. This wrecked boat gave us as much data as we can expect. Now we have to optimize this data exploitation and to give the museal boat a long and stable display life.